Hi, I am RPDM Rajapaksha under registration number 4135. In this video, I am going to explain my Kafka order processing system which I implemented for Big Data Assignment 1. The main idea of this project is to build a small distributed system using Kafka, where a producer sends order message in our format. A consumer calculates a running average of order prices. We have written logic for temporary errors and a dead letter queue for messages that cannot be proceed. This is the high-level architecture of my system. At the bottom, I have Kafka cluster running in Docker with two main topics: orders, the main stream of the order events, and orders DL queue, the dead letter queue for failed events. On the producer side, a Python program generates random orders, serializes them using the Auro schema, and publishes them to orders topic. On the consumer side, another Python program subscribes to orders, keeps a running average of the order prices, and uses retry logic if a message still fails after. I am running Kafka and Zookeeper using Docker Compose. In the Docker Compose YAML file, I use the convert images, CP Zookeeper and the CP Kafka. Zookeeper listen on port 2181 and the Kafka on port 9092. To start the cluster, I run this command. After that, in Docker Desktop, you can see both containers running. This gives me a local Kafka cluster for the assignment. To ensure a consistent message structure, I define the order format using an Auro schema in this file, order.avsc. The schema defined one record type called order with three fields: order ID, product, and price. Both the producer and the consumer load the same schema, so they always agree on the structure of the message. Now I will explain the producer. At the top, the program loads the Auro schema and configures a Kafka producer that connects to localhost 9092. Inside the main loop, the producer creates a random order ID, a random product name, and a random price. Uses fast Auro to serializes this Python dictionary into Auro binary format. Send a message to the Kafka topic orders. Prints log line with the produce order and the Kafka offset. The producer keeps running and generates a continuous stream of order events. This simulates a real e-commerce system producing orders. Next is the consumer. It subscribes to the orders topic and uses the same Auro schema to deserialize each message. The consumer maintains two state variables. One is the count and the other one is the sum prices. For every valid order, it updates these values and calculates average price. Then it prints the current order together with the updated running average. This demonstrates real-time aggregation on a data stream. Now explain the error handling. The actual processing is done in a function process message. A wrapper function handle message with a retriev, calls it with the maximum of 3 attempts. If a temporary error occurs, for example, a simulated issues like a database being unavailable, the consumer waits briefly and retries the message. If a permanent error occurs, such as an invalid price value, the message is not retried and is sent directly to the dead letter queue. If all retrieve attempts fail, the message is also sent to the DL queue with the reason retries exhausted. This shows how a streaming system can recover from temporary failure without losing data. All failed messages are published to a separate topic called orders DL queue. The payload contains the original fail record, the reason for failure, and the unique timestamp. The DLQ consumer.py program simply subscribes to orders DLQ and prints every message. This is useful for debugging and for later manual for batch reprocessing of problematic records. First, I start the main consumer. It is now listening on the orders topic, ready to process message. In the second terminal, I start the producer. On the left, you can see the producer continuously sending orders, and on the right, consumer printing each order with the update running average. In the third terminal, I start DLQ consumer. After a while, when simulated errors occur, you can see DLQ messages appearing here with the failed record and the reason. This end-to-end demo shows that the messages follow from the producer to Kafka, then to the consumer, are aggregated, retried on temporary failure, and finally routed to the DL queue if they still cannot be proceeded. To summarize in this assignment, I implemented a Kafka-based order processing system with Auro schema-based serialization, a producer generating streaming order events, a consumer performing real-time running average aggregation, a retrieve mechanism for temporary errors, and dead letter queue for permanently failed message. The system runs on a local Kafka cluster using Docker and is fully version controlled in GitHub. This completes my Big Data Assignment 1 on Kafka order processing. Thank you for watching.